how do we define piecewise functions in Wolfram Mathematica? Well, we have to start with is pressing ESC or escape button, PW, escape button again. Then you can enter whatever you want, x plus 10, x for x less than 0, Control enter. Control enter, you just need to hover over that. There is a smaller problem, of course, is that at first, when creating whatever you need, the piecewise function definition, you just need to press Control enter. So you have two rows where you can define things. So it's easier to add new rows when you need to. Let me show it to you. X greater than 0, now you press Control enter, and as you can see, the rows can be added. There's some mishap with that addition when you only have a single row. Just what happened just what happened right now. So we can put it behind the function, do a delayed set for it, and then we can plot it for x, and x will have domain from infinity, from negative infinity to infinity. And as a result, we get our function. This is practically it. Now, we need to go about the expansion of algebraic expressions or polynomials and putting those together. We already went over that expression before, but we didn't go over factor. Factor just does the opposite what the expand did, and it puts the it puts the expanded factorized equations into its original form. Now, another thing we have is together, that is partial fractions. When we have to add some partial fractions, for example, 1 plus x plus 1 plus 1 x minus 1, and it will instantly do it. No need to do all those tedious calculations. And if we want to, we can set it apart just as easily. That's it. Now we can collect the like terms as well. That is x plus y, xy plus yy, and we will collect it in terms of y or x. And well, we need just a slightly more complex example in order to really see the difference and how's happening. Y plus cxy, and if we solve it for x, we get this. I mean, collect it for x, right? We can also collect things for y if we want to, or for x and y together. As you can see, in both cases it changes the input somewhat. Now we can also do simplification of expressions, such as simplify sine of x squared plus cosine of x squared, and as a result we get 1. There's also another function which is full simplify that works as well if you want to do that, but we'll just move forward and cover a different thing, and that is an additional ability of simplify to simplify functions. And that is, if you have a function such as square root of x squared, simplification will not yield something different, so to say, but you can add an additional condition, such as we don't need, let's say, the domain to be less than 0, in which case we can just simplify it to be 5 seconds. We just need to correct what we just inputted, and yeah. And if we don't need any input from x less than 0, the square root of x squared can be approximated as just x from 0 and onwards, excluding 0, of course. Let's just try to plot square root of x squared for x with a domain from negative infinity to infinity. And yes, as you can see. Yep, for quite some time it can be just approximated. Yeah, it bends because we have this infinity, right, at one end. But if we look at the values and how they grow, they're practically the same. That is, we can take negative 10 to 10 as a better example, and as you can see, it looks like an absolute value function. Now, how do we use the output of solve? We did solve equations before we solve, and what solve returns, if let's say we have a system of equations just like this, and we solve it real fast, 34, and what happens is that we get this x2 and y8, and the question is, how do we use that? And to use that, it's very simple. We just need to use the substitute expression, and then just use the output as it is, and the substitution will happen on its own, just slightly differently, like that. As you can see, we got the x from the output, and if we want to get the y from the output, we can get that too. 5 seconds. It's not doing it. It's not doing what I wanted to do. Yeah. Yeah, so practically let me just clear x and y, just in case. And yeah, that's because the last input practically changed, so let's just copy paste it. And now it will work just like we want it to work. And that is, if we want to multiply x by y, it will happen too, just like that. And that's practically it.